In this video, we are going to review conservative vector fields and how we compute work integrals. Well, actually, we wouldn't even have to integrate when the field is conservative. First, let's check out to see if it is conservative. The field consists of two components, and there is a difference between checking if it's three components. You would have to find curl and make sure that the curl is 0. But here, we only have two components. Let's write them down. So I've got 24x squared y and 8x cubed minus y e to the power 9y. The first step to check that it's conservative is to denote the first component as, let's say, p, and the second component as q. We want to know if p derivative with respect to y is equal to yes or no derivative of q with respect to x. If that happens, then yes, this field is going to be conservative. Let's check that out. Taking the derivative of 24x squared y with respect to y and treating 24 and x squared as just numbers, that'll become 24x squared, right? Because number y derivative is just a number. If I want to take derivative of 8x cubed minus y 9 e to the 9y. So it looks complicated, but it's actually going to be very nice because when you take the derivative with respect to x, remember that you treat y as a number. Whenever we're subtracting, we are just taking the derivative of each term. Derivative of 8x cubed becomes, so 3 goes in the front, that'll become 24x squared. And the good part here is that y e to the 9y does not have an x, and that'll be 0. And guess what? 24x squared and 24x squared are the same. Yay! Which means that this vector field is conservative. What does that mean? What it means is that your vector field can be written as gradient of something, and that's something we usually call the potential. Okay, and it comes from physics. How do we figure this out? It's actually not that difficult. Think about what is gradient. Gradient would be the partial derivative with respect to x and partial derivative with respect to y, since we only have two components. What you are trying to think about is what function do I have to take the derivative of with respect to x and get the first part, and then I'll take the partial derivative of the same exact function, but this time with respect to y, and get the second part. In order to figure out this one function, I'm going to undo the derivative with respect to x. I will take the first component, which was 24x squared y, and I'm going to undo the derivative with respect to x by integrating with respect to x, which should give me that potential function. All right. So with respect to x, 24x squared y. Think 24 and y are multiples, which we keep. We will have 24y right here. Then integral of x squared becomes x cubed over 3. Now, the 3 will cancel with 24, and that'll just be 8. And you think that that's it. I mean, we're done, right? No, we're not done. Because when you take the partial integral with respect to x, there could be a constant. So there is a plus. Remember that plus c that we do when we have only one variable? Well, if that happens, this c could have the other variable. Because remember, when you're integrating with respect to x, you're treating y as just a number. And it is possible that you are still missing a term that has only y in it. You are not done. You will have to also integrate the second part, the second component. So this right here must be the derivative of that same function that we were looking for, but now with respect to y. So now we're going to undo the derivative by integrating. So we get 8x cubed minus y e to the power 9y. And we want to take the integral of that with respect to y and see what happens with that. Let's do each part separately. 8x cubed, when we integrate it with respect to y, well, it doesn't have a y, so it's just a number. How do we integrate a number? And don't tell me that's 0, because it's not. This is integral. We're going to multiply it number y. And here we've got a second term, and that second term is not that easy to integrate, especially if you forgot that you can't just integrate y and multiply by integral of e to the 9y. If you ever try to do something like that, the calculus teachers are not going to be happy with you. Whenever you have a product, you cannot just integrate each part and say, okay, well, this is just going to be a product of integrals. No, that is not how it's done. Well, if you want to know how it's done, there are two different things you can try. First, substitution. If this was squared, I would try substitution, because when I use u equals 9y squared, du will become 18y, and y cancels, and so it will be good to do a substitution, but unfortunately I don't have it. And so I need to integrate y e to the negative 9, I'm sorry, e to the 9y. I don't know why I keep saying negative. E to the 9y, I need to integrate that. This is integration by parts. The way I do it is I create a table, okay? The table will have D as your first column and I as the second column. Now, in the case of a product of a polynomial, which is y, and exponential, you need to remember that polynomial always goes in the D column and exponential will go in the I column. I don't have time to discuss this. This is really a topic of calculus 2, how we were doing this. Now, here's what we do. We're going to differentiate the D column, and at the same time, we're going to integrate the I column. So if I differentiate the D column, that becomes 1. And then I differentiate it one more time, and then I get 0. Once you get 0, if you started with a polynomial, eventually that's going to happen. If that happens, then you stop. Now, at the same time, we need to integrate the e. So it's going to be e to the 9y, which is going to be 1 over 9 e to the 9y. Okay, integral of e to the ax is 1 over a e to the ax. Now integrate one more time. Another 1/9 is going to go to the front. 1/9 times 1/9 is not 1 over 18. That's actually 1 over 81. Okay, and then we get e to the 9y again. Okay, one more step here. First of all, the rows have to have alternating signs. So we're going to start with the plus. We'll always start with the plus, then minus, and then plus. The final step is to multiply this way, and stop. That's it. We're done with the integration by parts. And remember that we're going to subtract this. So I will put it in parentheses. It's going to be 1/9. We always put the number in front. Then y e to the 9y. And then it'll be minus 1 over 81 e to the 9y. Okay. Now, this possibly has plus something else that has only other variable in it. This will actually be C2, some other constant. And what we want to do now is we want to compare the two answers. So let me rewrite them side by side. So the first answer was 8x cubed y plus something that has only y in it. And then this is our second answer. Now, these two answers must be really one and the same thing. Both of these should be the same function f. So what's what here? One thing to note here, that we have something called a mixed term. 8x cubed y and 8x cubed y is a mixed term. Mixed terms must always be the same. Otherwise, there is no way to get the same answer, right? You can see that if this was different, how would you get it the same? Because this has got to be the same answer. Now, the C1 of y, that's the part that we just found over here. That's something that we were missing that only had y. Now, do we have anything that has only x from the first term? No. And that means that I'm already done with my potential. That will be 8x cubed y minus 1/9 y e to the 9y, and then plus 1 over 81 e to the 9y. Okay, looks like that's what is going to happen here. Now, because this is step by step and I do want to check my answers, I am going to enter them. So 24x squared, 24x squared, are they the same? Yes, they are. Conservative. Now the potential. So we've got the potential. Let's see if we can write it down. We did have to work very hard on it, but that's what we got. Okay. All right, we got it. Now, the next part is to find work. Okay, how do we find work? Like, generally speaking, it's a long process. Finding work, you have to integrate. But if your force is conservative and if you can actually find the potential of this force, this is going to be pretty straightforward. All you do to find work is you're going to plug in the end of the path of your curve into the potential and then subtract the start of the path. It just means we are plugging in something for x and y and then something for x and y and subtracting, and we don't even have to integrate because we are done. That's all there is to it. And it looks like they give you a square root function, right? It's t square root of t, and it looks complicated. What am I supposed to do? Integrate here? No, you don't, because all you have to do is figure out where does this path start and where it ends. Where does it start? Well, the starting value of the parameter was 0. So if you plug in 0 for t and 0 for t over here, that'll be 0, 0. So the start of the path is 0, 0. How about the end of the path? Well, that's when t equals 36. So this will become 36, and then square root of 36 is 6. And now we just have to substitute, again, substitute the end of the path first. Now, decimal values are not allowed, so they don't want us there, so we're just gonna use symbolic. Okay, so we're gonna do 8. Instead of x, we're substituting 36, so 36 cubed, multiplied by y, well, that's 36. Okay, so I continue substituting the end of the path first, so it's 1/9, then times y, which is 6, and then times e to the power 9 times 6. And then plus 1 over 81 e to the power 9 times 6. Okay, I substituted, and that's what I got first. Okay, minus. Now I want to substitute the start of the path. Well, that's 0, 0. If I substitute 0 for x, 0 for y, the first term will become 0. The second term will also become 0 because y is 0. However, the last term will not, because hopefully you know that e to the power 0 is not 0, it's just 1. So that's 1. Oh my goodness, this is a lot of terms here. Okay, well, let's see if we can simplify it a little bit. I don't know if we can really simplify it. Okay, it's just really ugly stuff here. So, okay, so this is minus 1 over 81. Oh my God, I'm not putting that in there. Okay, it says decimal values are not allowed. Okay, fine, whatever. Let's see if we can. Oh my God, what in the world is that number? Okay. This is going to be a huge answer. So this is 6 over 9. That's minus 2/3 e to the power 54 plus 1 over 81 e to the power 54. I have not seen anything uglier than that. Can you believe that that's correct?